And so the idea, we call the Big Bang because Fred Hoyle, who had an opposite theory, was trying to make fun of it, so we call it the Big Bang. But we think it is this time when the scale factor, the space itself is expanding, began expanding or was expanding from a very small scale. So it is conceivable the universe is infinite. It's probably it's a little more probable, I think, that the universe is finite but extremely large, either just closed like a sphere that we close, and we are just a very teeny section. It's like being a little part inside of a water melon, which is a little piece you don't see what's happening at the end of it. And that's one of the things that we're looking for and testing very carefully. And we're trying to understand what are the physics for the actual creation of space and time. That's why I'm showing that picture of seeing those tiny variations and seeing no long, sharp edges in it. It tells you whatever the force was that created space and time, it's an amazingly linear, simple force, opposed to on the crust of the Earth, there are nonlinear effects because there are strength of material issues. There's uneven cooling. There's lots of things going on. That's why you get these plate tectonics and so on. Yes.
2 questions. Do you believe in God? And if there is life anywhere else?
Okay. So I usually avoid answering the question about do you believe in God, especially in the early days when we first made the thing, because there was a lot of religious news involved in it, particularly in England where they were having a crisis in the church. And so it was first on the front page, then it was on the science page, then it was on the religious page, and back around. So it stayed in the newspapers for almost a month straight. And there were many people convinced that this was a sign, for a religious revival. And they were asking questions about what does this mean about God, and what is this God? And so you then get the question about what is God, and what is his role, and what is so it's a very complicated theological question. So we were talking about a little bit about how you define this kind of stuff. So I usually try and leave that to their own. Each person has their own view of how they fit in what their relationship is with God and everything else. And so I usually don't try and give my comments on that. However, on the second question, is there other life in the universe? I always suspect that there might be, but I often have been teaching a course called The Universe of Myself, different languages, and French, the universe of moi, and so forth. But there, one of the things we do is talk about how the world is, how the forces and stars relate to people's every life, and then how the world was created, how life came into existence, and so forth. And during this time period, during the last 5 years, there's been an incredible explosion in understanding about planets around other stars. And it started the first time that I was teaching the course 5 years ago, we knew of maybe 30 planets around other stars. And now we have more than 2,000 candidates, but we have a lot more statistics about them. And there's a change because the Kepler satellite came on. There's much more information available. And because of that, we know a lot more about how many planets there are around stars and how many might be in what scientists refer to in a loose way as the habitable zone. That is, if a star is putting out a certain amount of power, you want to be in a region where the water is liquid and not frozen all the time and not boiled all the time, but liquid most of the time. There's sections, large sections where it's liquid. And you can do studies about that, and that's the number that I was giving you, that is roughly on the scale of 4 billion in our own galaxy, and there are hundreds of billions of galaxies we can possibly see. So the answer is it's 4 billion times 10 billion or 100 billion or something like that. Possible sites, life to form, life like we know it. And then one of the arguments you have is how what is the range that life might exist in, right? We're biased towards carbon-based, water-dependent life because that's what we know. And when you do an inventory of the solar system, you realize the Earth is by far the place for life to be. Life came into existence in the Earth almost as soon as it possibly could. There's no evidence that it was coming into existence right at the period of the end of the cometary bombardment. So when the solar system was formed, there was a lot of debris left around, and a lot of that had to be swept out. And that's why there's craters on the moon and the Earth. There was this huge period of bombardment. And in fact, it appears that life first began to appear on the Earth almost, at the end of that period, right? Whether it's just before the end or near the end. And so, you start saying, well, does that mean life is very likely because it came as soon as possible? Or in order for there to be intelligent life, they ask the question on the Earth, we had to get started. Because if you think about it, there are many inventions that have to be made to make a cell from a simple organism into a very complicated organism. All life on this Earth is cell-based. Everything that exists on the Earth starts with two gametes, singles fusing together to make a single cell, or dividing from a single cell, and then growing up. So we're all cell-based. So it turns out there were a huge number of inventions or developments that had to happen to make cells really the robust, powerful things they are, and allow them to live together in organisms like human beings. There's a tremendous number of developments that had to happen. And the question is, over how many eons does that take? If it's 40, you can make some guesses. But you don't know because you only have one example. So when you do a search around the solar system, so I made my top 10 list for the solar system, and it's clear Europe was number one, right? Because we've been to the moon. When you look at the pictures of the astronauts standing on the moon, it doesn't look so good. Even when there was life on the moon, it didn't look so good for life. And that's when I was giving that quote. I went to the 50th anniversary of Men in Space, and the astronauts, first one, in fact, said, when you're on the moon, you can hold out your hand at arm's length and put your thumb up and cover the Earth, and you see nothing but the dark sky and some stars. And so on that trip, you could do that and see galaxies, see the darkness. But anyway, it's clear that the trip to the moon impacted Neil Armstrong very much. It's also clear that they didn't find any signs of life. But you can go around, and there are potential places, including even in the asteroid belt, and so forth, where life could exist. Right, kind of thing. But you have to make certain assumptions about it. But there are so many possible sites that it seems extremely likely to me there's life other places. The real question is, how developed is that life? Is it intelligent? Have the civilizations lasted a long time? Right? So one of the questions that students ask when we have this kind of discussion is, there's always a bright student who comes up and says, how long does civilizations last? Do they burn up all their fossil fuels and choke them? Right? And it's because they read the news and they hear the negative and they don't have the experience to do the calculations to see how rapidly it's happening or whatever. When you hear the news and glaciers are calving and global warming is coming much faster, it's very hard to make that judgment without either being an expert or looking at the perspective as to how endangered it is. But there are many treaties on that. But the fact is, we only have one place where we've seen life. However, 20 years from now, I believe we'll have seen evidence of life on other planets, because you can now that you've found life on other planets, you can now propose experiments where you go to space with telescopes and you can try and look and see what elements are in the atmosphere, and see if you see oxygen, see if you see water, see what you see. And that happens occasionally. Every now and then there's a star with the right orbit where things happen the right way, so that you can see the light from the star shine through the atmosphere of the planet, and you can learn a little bit about the atmosphere of the planet. But you can develop tools to do that. So one of the things that's going to be exciting over the next 20 years is not only learning a lot more about how planets form and what range and where they are, because we find some planets in some places, but it's not surprising because the tools we're looking for planets big planets and close to the stars, much more easy than further out. And so you have bias in your selection. So there's very many exciting things that are going on about how planets form and maybe how our solar system form. And we're also going to then see how they develop, how stable they are. We found situations where there is a double star and a triple star with a stable planet around it, where you could even have life. Whereas before we found it to be single stars. And the question is, will we see evidence of that? And there are even people trying to propose experiments to put up very good telescopes to look for light on a planet. If you can see a planet, and you can see the difference between day and night on the planet, you should be able to see light shine on it. If you ever see the pictures of the Earth at night, it's very difficult experiment to do with science progresses. So there is, and my expectation is over the next 20 years, we're going to see evidence of life either in the solar system, that'll be very primitive kind of life. That's why every time they get excited, people find evidence of water on Mars and Mars and things like that. There might be some very primitive life on Mars or some other places. And but we're going to see evidence from other solar systems, extrasolar systems, extrasolar planetary systems. We're going to start seeing evidence coming in that there is some signs of life on some of the other planets. Now, it's a lot simpler to think about making simple bacteria or photosynthesis than it is to think about making complicated aggregate cell organisms. And if you look at algae, they're not very, they can make these long kelp beds and stuff, but they're basically single cells. It takes so long to develop. But when you start looking for dolphins, they're much more complicated to build. And so I think that it's very likely that within 20 years we'll see evidence for life. It may be something longer than that before we find evidence for intelligent life, but we don't know. I had another movie to show you, which was a section I had on Contact, where Jodie Foster is the heroine who makes the discovery of the signals, and it's for this thing to go. And the fact is, there are different ways you can look for signs of intelligence, right? Of course, you don't know. I mean, it'd be very hard if you were an ancient Aztec to predict that people were using cell phones and televisions. You know, the technologies that can develop over time can be very different. And there is a very famous quote from Enrico Fermi when they had a lunchtime discussion about alien life in the middle of the afternoon. He said, "Where are they?" Because you can do a calculation about how fast a species that actually gets that planetary travel, gets interstellar travel, how long it takes them to colonize the galaxy. And it isn't that long. They propagate out at the direction of the speed of light because they send out robotic probes. And you don't send people and have them in the factories. You send robots and have them in factories. You have to understand how flexible your labor force is. Future problems are. And so there are lots of potential ways where we could discover signs of intelligent life. The universe, though, you said with pictures, is extremely big. The chance of somebody coming by here to visit is extremely small. The chances of us sending probes out and actually making some contact or doing very careful searches of nearby systems. So there already is a steady search going on of the 50 nearest stars, plus some other kind of at the Allen Array, which is a prototype for this work. There are these searches going on where people are using the fact that there are large arrays, and those large arrays can spend part of their time doing searches in places where there are stars, looking to see if there are any signals.
Dr. Smoot, you have a couple of more questions?
Yes, sorry, I got carried away.
No.
I'm going to have to teach this again in about 3 weeks, so I'm thinking about it.
So
yes,
we have
sorry.
a lot of people. No, I apologize. Please.
Hi, I'd like to know something more about the projects that you mentioned about search for dark energy, especially the one where you said you have Mexican produced. And also this last video that you showed, is it available somewhere so we can see it again or share it with others?
It was posted on the American History Museum webpage. I don't know if it's still there or not. I haven't checked. I haven't checked it.